Welcome to this video where I'm going to demonstrate to you a smart home light sensing project using a photoresistor light sensor module that I am currently pointing to along with RGB LED light that is being programmed using Raspberry Pi Pico in Python. And the program basically picks up the reading from this light sensor module that basically sends the light intensity from a direction, and the brighter the light is, the lower the electrical resistance is that is being shown on the back of the screen, which I'm currently pointing to. So this reading you see, this is an analog reading, and when the light is brighter, this analog reading is lower, but when the light goes darker, this analog reading will go higher. So right now between 0 and 20,000, I have programmed it to show a green light. When the light goes up between 20 and 40,000, then this green light will turn into a blue light. And when the resistance goes between 40 and 60,000, this is alarm is gonna go off and show an emergency with a flashing light. So let me give you a demo of this. Right now you see the reading is 12,000, 11,000. I'm gonna put my hand on the photoresistor to make it darker. There you go. Now you see the reading on the back end. It goes above 20,000. That's why the light becomes blue. Now what I'm gonna do is I'm gonna move my hand further. When the reading is gonna go above 40,000, it's gonna the alarm is gonna go off and it will show an emergency with a flashing light. So I'm gonna make it even darker. See the reading on the back screen is going higher the more darker it becomes. So okay, I'm gonna move my hand and okay, here you go. See, it is now 40,000. As you see, on 40,000 it's flashing light and the buzzer goes off. So the moment I'm gonna move my hand, if it goes between 20 and 40,000, the light is going to be blue. Here we go. And when I'm going to completely remove my hand and give it a bit more higher light, the photoresistance reading is going to go below 20,000 and the light is going to turn into a green light. Here we go. So that's the demo. So what we used in this project is this small photoresistor module. So this is the module. Let me now show you how we can actually cable this one. So what I'm gonna do is I'm gonna take the cable off so that we can actually explain it properly, the cabling. Let me show you how you can cable this, right? So you see the VCC, ground, digital output and an analog output, right? So first let's talk about the VCC, the first one, right? So if you look at it on the back of it, the first pin that we plugged in is the red cable that goes into just behind the VCC, and from there we have plugged that into 1 because that's where the voltage 5, because VCC is the power source and it needs to be connected to 3.3 voltage or 5. So we chosen pin 1, right? That gives you basically 5 voltage on Raspberry Pi Pico. And the second one is the black one, which just needs to go behind the ground pin, C and D pin, right? That's the black one. So the black one goes all the way on the front of this, right here. This one, I'm just pointing that to. This is your black one, right? This one, right? So that goes into, if you want to see it, in number 3, because on the Raspberry Pi Pico, number 3 is on this side of Raspberry Pi Pico is basically ground pin, so you can plug that one in there. And the last one, we're not using here the digital output but the analog output, this one, right? So this one we have used a green cable, as you can see, right? And that run all the way through into pin 9, and that's where we plugged in our analog output pin. It's GP27. So when we write the code, we'll refer it to as GP27. It just needs to be plugged into pin 9 here. You see here on that there's number 9. So if you look at the LED light, I'm going to show it to you the way this one is programmed. So LED is LED light, as you can see here, right? I show you. So it's got these legs, right? So the leg that is the longest one, the long leg, is basically your ground. So in the LED here, this is from the left to right. I'm going to actually point that to you here with this one. So this one here is your ground. Sorry. So this one here, which I'm pointing right now, is your ground. Okay. And that's basically behind that is the black cable you plugged into. And this is your red color. Okay. This is your green color. And this last one is your blue color. And accordingly, I have picked up the same color cable. So behind this leg, I put a blue, and then I put a green here, and then I put a black on the long leg, this one, and this one I put the red because it's a red color. And accordingly, if we look at it, these cables are all plugged in here. Okay. So this from here, the black one, as you can see here, this one, right? It goes into number 8. The red one goes into number 9. Green one goes into number 10. And then blue one goes into number 11. And these are the pins that you need to use. Okay. And finally, we got this buzzer, right? The buzzer, I'm going to show you. Buzzer, when you take the buzzer off, right, you will see here 2 legs of the buzzer, right? One is long and one is short. The long one should go into number 1 like this, right? And if it goes number 1, the short one will automatically goes into number this is 27, isn't it? Yeah, 27. Right, so I push it in there, and in number 1 is your output pin. So that is the red wire I used, and the short leg you will use a black one because that's a ground again. And if we run it through like this, here on the Raspberry Pi Pico, you could use the black one, the ground one, to go into number 18, and you can use the red one, which is an output pin on number 19, and we'll refer in the code this 19 pin as GP14, right? And you can read about the GPs behind the Raspberry Pi. So see here, you can see all the readings of GP, what they're called, what is ground. Ground is GND, and GP is 1, 2, 3, 4, 5, and all those are on the behind because we can't see it here. So I just use this numbering system. So this way we can cable the whole Raspberry Pi Pico with our photoresistor light sensor module and an RGB LED light, and also a small buzzer that's going to make the sound. The next step, what we're going to do is we're going to now program it step by step while explaining the code to you. Actually program this project from scratch. So first thing first, you need to import all the modules and classes. So this RGB LED class that you need to import from Pico 0 module. Before you use this line of code, you need to make sure you have installed Pico 0 in Tony. And I have a video how to install Pico 0 in Tony under my Raspberry Pi channel. If you get an error on this, you need to follow that video to install that module. And the second one, we're going to import machine because we're going to use pin from machine, and also we're going to import time because we'll be using time. Now the first thing what we're going to do on this code is we're going to actually program to get machine to read analog to digital reading, because we are using this analog output from our photoresistor light sensor module. So I showed you in the video that we are using GP27AO, and that's basically the GP. So we need to provide that, so we will get this reading, live reading through this, and then we do RGB with our basically RGB light, and we're going to do is RGB LED. And what we're going to do is we're going to pick up the 3 colors there, right? So we're going to pass on as a parameter. This is on GP6 red, and green is on GP7, and blue is on GP8. While I was explaining you in the video, I was referring to the pin numbers. because GP is behind. You couldn't see the GP number because it's behind the Raspberry Pi Pico, but all those pin number, the red wire refer to for the RGB light to 6 GP, and green light was basically the green cable GP07, and the blue was GP08, and that's why I need to provide the GP number here, not the pin number, right? The next one is that we need to program the buzzer, right? So buzzer is the pin on the machine. We need to pick up the pin from the machine, right? So buzzer was the last one. Remember the GP14 I explained in the video, and because it's an output pin, because we're sending an output to buzzer to make the sound, so that's why we need to pass on the pin out parameter to the buzzer. Now what we're going to do is we're going to write a while true, which is our a loop, infinite loop, which is going to continue until we stop it. So because we want the reading, so let's pick up the LDR value reading, right? From LDR, we have already defined the LDR here, right? This one. So we're going to say LDR dot, we're going to pick up the reading. So LDR dot read, okay, and what we're going to do is use 16, so it's going to pick up 16-bit reading, right? So it means because the reading can go up to 65,000 plus, so it will pick up the integer value so that it can pick up all the reading, and then best is to print it. So what you are seeing, the reading was being printed on the screen in the video in the beginning. That was because of this print command, right? Because we're just gonna use that. And the next thing we're going to do is now we're going to put our control structure. We're going to put our if-else commands, right? So first thing I'm going to write down if command, right? So that would be on the LDR reading, right? So value, LDR reading value. If LDR reading value is greater than 0, right? And LDR reading value is less than 20,000. And remember which color light was it? That was green, and because the intensity is lower, light is brighter, so it should turn on the green light on. And now we need to set our green light on by saying GB color is equal to, okay, and here we're going to pass on the green value, which is 255, 0. So that's basically green color light. We set the color to green, and the buzzer should not sound, right? So that's why we need to set the buzzer pin off. So by putting a value is equal to value parameter is 0, that means the buzzer pin will not go off. And the second elif command is going to be if LDR value is greater than 20,000, okay, and less than LDR underscore value is less than 40,000, then our light should be blue. Remember that when we do the demo for this one, our RGB color was blue, and for blue color we need to pass on the value as 0, 0, 255. You can give a space or you can leave the space as you wish, right? So both will work fine. Now also the buzzer will not go off here as well. So buzzer pin is going to be value, because we don't want to make a sound on the blue color, so we're going to set this to 0. Then the final one, elif, right, LDR value, okay, is greater than 40,000. That's where we're gonna sound the panic alarm, right? And the panic alarm was basically blue red light flashing, right? And value, oh sorry, value, wow, what is happening? Value is spelling wrong. So less than, I would say 60,000 here. I would put 65 actually, or maybe 66 I'll put, because it can go up to 66,000. So under that it's gonna just give this blue light, right? So it's gonna go up to whatever the integer value can be taken. I think it's 65,000 something. So I'll put 66,000 just to be on the safe side. Now what would happen under this if the intensity of light resistance reading goes between 40,000 and 66,000? You need to actually, first thing you need to do is you need to turn the color red, blue and green flashing light. So for that one, what we need is we're gonna say RGB dot color, right, equal first turn red, right, 25500, right, that's red, and then go to sleep, right, so there's a time dot sleep, give a little pause there, right, so we're gonna do say 0.2 pause, and then we're gonna do RGB dot color is equal to, we're gonna turn it into, after red we're gonna turn it into blue. Okay, so blue is actually 0. Well, let's do after this one red, we turn it into, no, this is the green one, right, so no, this is the red one, after red we turn it into so red, blue and green, so we use the blue one after that, so, or we just go with the flow, I think 255 here, right, and then we give a timer to go to sleep, right, so we're gonna do 0.2 here, and then the last color code is equal to 0, 0, 25, and that's basically 255. That one is blue, right, so this is gonna be red first, then green, and then blue, so that's how it's gonna flash between the three color, and at each color I'm going to give a time to sleep, right, so this is going to be 0.2, right, so every each color is going to go to sleep, and then what it's going to do is going to give the buzzer sound, right, so buzzer is going to go off here, because for buzzer to make the sound we need to pass one parameter, as you see here on top, we for each buzzer value we pass 0 here, we also pass the 0 on top, and this time we're passing 1 because we want the buzzer to make sound and also make these flashing lights under this if the value is between 40,000 and 66,000. Okay, that means the intensity of light is really low and that's an emergency, so make the buzzer down. And finally we just put an else command so that we turn off the buzzer if if the value is not any of these, right, then you need to, oh, this is underscore value, we just make it 0, and also turn our RGB color light off as well if the value is not within any of those, so there's no color. Okay, and now this is the it, and finally you need to put a timer under the else, right, so give a bit of timer there. This timer is in case every time the loop runs, it's going to give a little gap there for this one, and that's for the loop, right, because that's why I put it under the else, not here, right. This timer is for this flashing light, but this timer is for the loop, right. So this is how we actually program this. So our program is finished and we just can now save it, right, and then we run it. Let's see. Okay, we got syntax error. You're gonna get error always, but the good news is that you will be able to fix those errors. So let's see what error we get here. Line 12, we forgot to put this, okay, just above line 12, because when you start the if, you gotta put this, and you need to also put it here as well, and also here, because this is important, otherwise you get an error. Okay, now bingo, so you start getting the reading here. So you see the intensity of light is 11,000, and I can see, you can't see it, but I can see it, my my reading here, and I'm going to actually show you. Let me flip the camera and show you this live, what is happening there on the video side of it. So this is what you see when I ran the program. You see this, and now I'm going to put my hand, the light is going to go up, right, 22, and it turns blue, and when I'm going to put my hand further, it's going to go, the buzzer is going to go off. Okay, there you go. So our program is perfectly working. Here you go. Enjoy the project. I hope you are able to use this code and also the cabling in any other scenario, whether you can program it whatever you like. So thanks for watching.